All right, here we go. This is a pretty short one today. Sets of outcomes and tree diagrams. Okay, so this first slide is just, it's pretty basic, nothing's terribly complicated here. So we've got this example. Experiment, we make 2 telephone calls, so I'm like a telemarketer, one right after another. I note basically in order whether each is completed. So in other words, if they answer the phone or don't answer the phone. So my set of outcomes is what we're going to describe, and we're going to form what's called a sample space. So basically, I can either complete the call or not complete the call. So you C and N to represent that. So I could either have, if I'm just making 2 calls, I could have complete, complete. I could have complete or not complete, not complete, complete, or not and not. Okay, that list, okay, this right here, that is known as the sample space. It's a set of all possible outcomes. That is a sample space. So you find all the outcomes, that's a sample space. So this one wasn't bad to come up with what they were. Larger sets will use what are called tree diagrams, which you've likely seen before, to kind of help us organize it and make sure we don't miss anything. Okay. All right, so I've got a quick little video here. Take a look at. I've got a video in the video. Think about that. So we're only going to watch a portion of this, just a quick introduction. Maybe.
A tree diagram is basically a visual way to write out a sample space and calculate probability. For instance, we can draw a tree diagram for flipping a coin 3 times. So the first flip could be heads or tails. So we branch these off from one, and at the end of these branches, we can put an H or a T for heads or tails. Now we can address the second flip, which again can only be a head or a tail, 2 possibilities. So from both the H and the T, we can put in 2 branches to represent the possibilities. If the first flip resulted in a head, the second flip could be a head or a tail. So at the end of the branches from the first flip being a head, we again put an H or a T. And we do the same for the bottom portion of the diagram.
So you get the point there. If you want to see that again, you can just check the notes out. You can watch the whole thing. Really, you only need the first half of it, though. So basically, with the tree diagram, we just go through each section of the tree is my stage. All right. So here's an example. Okay. Obviously, I coach baseball. I like using baseball examples. Works out a lot with probabilities. So we're going to pretend we have a base runner on first base. Okay. So there's first base, second base, third base, and home. Okay. So if he's right here on first base, okay, he's getting ready to do something. So he has, basically there's a few options that can happen. Either he's going to be on the next, I guess you could say the next play, or the next outcome that happens in the game. He could either be out, he could advance to second base, he could advance to third base, or he could score. Okay, I guess also he could stay there, but for simplification purposes, we'll pretend that he's not going to be it. There's no way he can stay there. Okay, so those are my options. So we're just starting out. Okay, he's at first base, so he can either be out. He's going to use O for out. He can go to second base, third base, or he can make it all the way around and score on that next play. So someone hits like a home run, or someone hits a double or a triple, and he scores. Okay, so if this is my first stage, so if he's out, he's done right there. So usually I'll make a little like circle over it, around it, just to show it ends right there. Okay, so that nothing happens, nothing goes off of that. All right. If he goes to second base, all right, what can he do after that? Well, he can either then be, so he's at second base, new batter comes up, new outcome, okay? He could either be out, he could go to third, or he could score. Again, we're going to pretend that he's going to do something. He's not going to just stay there. If he stayed there, then he would just have one more outcome, but try to make the tree a little smaller. All right. Same thing if he was at third, right? He could either be out, or only other option is he scores. Okay. If he scored in that first stage, he's done, right? He's going back to hang out on the bench for a little while, pull his mask back up, and social distance in the dugout. Right? The second stage, so this was now the second stage, which would be like the next batter. Okay, if he was out, he was done, right? Didn't do anything after that. So I'm going to just circle all the ones. Let me get that up there. I'm going to circle all the ones where he would be done. So this one, he was done. If he scored, he was done. Done there. Done there. Okay, so my only other thing now is, so now in my second stage, if I'm at third, right, I can either be out or I can score. Done with those. Okay, that's then basically shows my sample space. Okay, so big thing with this section is drawing the trees to try to find all our possible outcomes. Okay, eventually what this leads is so we can figure out probabilities. All right, I can figure out what's the probability of this person scoring, or what's the probability of them being out, or whatever. We need a lot more information to do that, but that's kind of an introduction. That's what the tree diagrams eventually help with, is with probabilities, and they make probabilities a lot easier. Okay, so we need to get good at drawing tree diagrams. All right, this is also kind of a stage and an introduction. Major league teams, really all the way down. I use it in high school, figuring out probabilities to figure out, should you bunt or steal or whatever. Okay, all this is it's probability and kind of stems from this. So, last little thing here. Okay, what's called the multiplication principle. All right, so if I have a multi-stage experiment, so let's say I'm, rolling a die, spinning a spinner, drawing a card, flipping a coin. I'm doing all these things in a row. Okay, example down here at the bottom would be something like that. So let's just say I'm flipping a coin, then I'm rolling a die, then I'm drawing a card from a deck. That's a multiple stage experiment. I'm doing 3 different things. They don't depend on the other one. Okay, if they depend on the other one, that's a little more complicated than this. But right now, we're just saying they don't depend on the other one. They're all independent of each stage. So we're going to say our first stage, if it has n possible or n sub 1 possible results. So maybe the first stage has 2 results or 3 results, whatever. Second stage has a certain number of results that they're regardless of our stage 1. In other words, they're independent of each other. And then our third stage has a certain amount, all the way up, however many stages you have, up to k stages. So 100 stages, 200 stages, 5 stages, whatever. All right, if that happens, if I want to figure out how many elements are in my sample space, we can just multiply how many outcomes are in each stage. Okay, so this was stage 1, had that many outcomes, stage 2, 3, and so on. We just multiply them together. So, example down there at the bottom. Stage 1 is flipping a coin, so we have 2 results. Stage 2, rolling a die, you have 6 possible results. Stage 3, drawing a card from a deck, you have 52 results. So if I say you're going to flip a coin, then roll a die, then draw a card from a deck, how many outcomes are possible? All we do is take 2 times 6 times 52. That tells you the total amount of outcomes. All right. That leads to then probability. Say I wanted to find what's the probability of getting a head, a 4, and a jack of diamonds. Okay. You could then find how many ways that can happen. You would divide that by the total in the sample space. Okay. Right now, we're not doing any probability yet. We're just finding how many are in the sample space. Okay. So that's it. That's section 1.4 on sets of outcomes and tree diagrams.